Hello everyone, today let's solve the problem number 198, house robber, right? So what the question states here, we are given an array nums, right? So we are given an array nums, you can clearly see here, we are given an array nums and nums of I represents the amount of money in the ith house, means this is present at the 0th index, first index, second index, third index, right? Zero based indexing. So you are a robber who cannot rob two adjacent houses. Means we cannot rob here two adjacent houses. We cannot rob, if we rob one, we cannot rob two. If we rob three, we cannot rob one. So that's what we cannot rob two adjacent houses. And our goal is to determine the maximum money that we can rob without alerting the police. So without alerting the police, we have to determine the maximum amount or maximum money that we can rob. That's what the question states here, right? So we cannot rob adjacent houses, and without alerting the police, the maximum amount that we can rob, that we have to return. So that's what they have asked in the question. So let's come to the first example here. Just give me a second. Yeah, let's come to the first example here. Just a second. So here you can clearly see we can rob house 1, right? Adjacent house we cannot rob, right? It will alert the police. So we can rob the third house, means 1 and 3. So basically, or we can rob 2 and 1 as well. We can start with 2 and we can rob 1 as well. So maximum we have to find out maximum amount without alerting the police. We have to find out, right? Here 2 plus 1 will give us 3 and 3 plus 1 will give us 4. So maximum of 3, 4 is 4. So in this case we have to return 4. So rob house 1, money equals 1, and then rob house 3, money equals 3. So total amount we can rob is 1 plus 3. That's what they have given here. So let's come to the second example here. In this case, let's rob the first house here 2, right? So then just ignore the second house, rob the third house, ignore the fourth house, and rob the fifth house. In this case 7, 9 plus 2 11, 11 plus 1 here, finally 12. So 12 is not 12 is what we have to return. In this case we can go with either 2 and 4 as well. In this case it will give us 7 plus 3 10. Basically we have to ignore that one, right? So in this case we have to return 12. So that's what they have written here. Rob house 1, money 2, then rob house 3, and then rob house 5. Nothing but 2 plus 9 plus 1 will lead us to the 12. So that's what we need to return. Simple to understand, right? Here. So this is what we need to do. They have given wonderful examples just for the sake of understanding, right? So I hope the question is completely clear. What we need to do is completely clear as well. First, let's discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. So first thing that we need to note down here is we will be going with the dynamic programming approach, right? So we'll be going with the DP, nothing but bottom-up tabulation, right? Or bottom-up dynamic programming approach. So I have considered the same first example that they have given in the question, right? So the first example that they have given in the question, that itself I have considered, so that it will be easier to understand the approach. We have already discussed this one, right? First we will be robbing house 1, then we'll be going with the house 3. Basically we shouldn't this one rob the adjacent houses because it might trigger the police. That's what they have asked in the question. It will trigger the police. Sorry. Yeah. In this case, we can check for 1 and 3, and we can check for 2 and 1 as well. So max we can rob here, the adjacent houses, maximum we can rob here is 3 plus 1. That will lead to 4. So 4 we have to return that one in the form of output. I hope this is clear. Let's come to step-by-step execution here, right? Nums we have been given 1, 2, 3, 1. The same example, the first example I have considered. Here in this case, first we will go with the house 0. Means we will rob 1. This one I am speaking of. We will rob equals 1, right? We will rob money 1. So next we will be moving with the house 1. Max of rob 0 is 1. This one we are speaking. Rob 0 is 1. So rob 1 is 2. We know this one, right? So maximum of rob 0 and rob 1, 1, 2, this will be max will be 2, quite obviously. Maximum of 1, 2 will be 2. Next, let's move on with the house 2. Max of rob 1, nothing but we are considering again 2, rob 1, and rob 2 this time is 3. Max of 2, 3 is 3. So, sorry. Oh, this one I forgot actually. Max of rob 1 is 2. This is fine. then we have to consider rob 0 plus house 2. Rob 0 plus house 2 nothing but this one. Rob 0 will be 1 and house 2 is nothing but 3 we are considering, right? Here 1 plus 3 will lead us to the 4. So max of 2 comma 4 will be quite obviously 4. So we will get the answer 4 for the house 2, right? So 1, 2 and 4 we got. Let's move on with the house 3, the final house here, right? So this will be maximum of rob 2 comma rob 2 and rob 1 plus house 3. Maximum of rob 2 here is this one. We got rob 2 as 4 here, right? Rob 0 plus house 2. For rob 2 we are considering rob 0 plus house 2 here. This one 4 comma rob 1 plus house 3. Rob 1 is nothing but here in this case this one I'm speaking of 2 plus 3. Rob 3 house 3 is 1. 2 plus 1 is 3 here, right? So 2 plus 1 is 3 here. Maximum of 4 comma 3 is 4. So we will return the 4 itself. In this case we will return 4. So don't get confused here. 2 plus 1 is 3, no doubt here. So this should be bracket here. Maximum of 4 comma 3 we have to consider. So here in this case max of 4 comma 3 is 4. So that's what we need to consider. So finally we got the output 4 here. So we will return the output 4 itself, right? We will return the output 4. So the output that we got is 4 and the output that they have mentioned for the example 1 in the question is also 4. So the output that we got is equivalent to the output that they have mentioned for the example 1 in the question, right? So the approach works absolutely correct in our case, right? So as we are familiar with the approach, let's quickly discuss the edge cases one by one, right? So first we'll be going with when nums is empty, right? When we don't have money. When we don't have money. So here in this case output we need to return is 0. So when we have single house, then we have to return 5. So this itself, right? So whatever the money that is stashed in the first house, that itself we will be returning here in this case. So let's move on with the third edge case here. We have 2 comma 1. So adjacent house we cannot drop. So just we'll go with the first one itself, nothing but 2. The money stashed in the first house. So here in this case we'll go with first one. We cannot go for the adjacent house. We'll go with this one. We cannot go with this one, or we can go with this one and this one. We cannot go with this one and this one. Either way we can go. So the output that we'll get is 5 plus 5 10, right? So I hope this is completely clear. These are the edge cases that we need to consider basically. Right now we are completely familiar with the edge cases as well as the approach. We are good to write the code now. So let's start writing the. So first what I'll do, we'll be making use of length of the nums several times. So I'll just assign this one to the variable length of the nums. This is fine. So the next step is, if there are no house present, we have discussed this one in the edge cases, right? This is the base case basically. So if there are no houses, then we cannot rob anything, right? So in that case we have to return 0. Means if n equals 0, then we have to return 0 in that case. So the next case is, we have when there is only one house, we can drop it directly, right? So for that one also we have to that one we can articulate in this way. So I can just give you, if n equals 1, then I'll just go with return nums of 0. This is fine. So the next step, so here maximum amount that is robbed till house I will be represented by dp of I, right? So I can just write here on this way. So I'll just go with int here, the variable dp. So let's give a new int of n. So dp of I equals maximum amount robbed till house I, right? So we know this one. So let's rob the first house. Means here dp of 0 equals first index, nums of 0, the element present at the first index. We know this one, right? So next dp of 1, nothing but max of the first or second house. We can consider this way, dp of 1, this is equals math.max. So we have to find the max of the houses, right? Maximum of the houses. That's what we saw in the approach as well. So we can articulate in this way, math.max of nums of 0 first this one 0th index and nums of 1, right? So this is nothing but max of first or second house, right? Next we have to iterate through all the houses to get the maximum, right? Maximum amount that we can rob, right? So here we will start from 2, as we have 0 and 1 we have already considered here, this one. Now we will iterate from the third house, nothing but I equals 2, right? I less than n. So let's increment the I. Simple to understand, right? So either we will skip the current house or we will drop it, right? Either we will skip the current house or we will drop it. So we will articulate this one in this way. dp of I equals current house means either we have to skip the current house or we will rob it first. So I'll just consider here in this. So I'll just consider here math.max of dp of I minus 1 comma dp of I minus 2 plus here, sorry. So did I miss anything? Yeah, this is fine. Just give me a second. dp of I minus 1, I minus 2 we have given. So along with the iterated value of the nums. Means either we are skipping the current house or we are robbing it, right? So when we are skipping the current house, it is nothing but dp of I minus 1, or when we rob it, it is then we will go with current house plus dp of I minus 2, right? So that's what math.max of dp of I minus 1 comma dp of I minus 2 plus iterated value of the nums we have given. So the final step here is we have to return the maximum money that is robbed till the last house, right? So I'll just go with return dp of n minus 1, last house dp of n minus 1. So this is it for the code. Let me format this one once and let me hit the run button. I hope this works. Let's see. Have some error here. What is the error? So I have not considered int here. Let me give int here quickly. So yeah, let me hit the run button again. Yeah, now you can clearly see the sample test cases are getting passed, right? So let me hit the submit button quickly. So you can clearly see the code works absolutely correct for all the test cases, right? So let's quickly discuss the complexities for the code that we have written. So the approach that we went with here is this one, bottom up dynamic programming, or we can just call this one as dynamic programming, right? So here the overall time complexity would be big of n. Why it is big of n here? Because we are processing each house once in a loop. Here, this I'm speaking of line number 15, right? So we are processing each house once in a loop. So next, what is the space complexity here? So overall space complexity would be big of n as well. Why it is big of n here? Because we are making use of the additional DP array of size n, right, to store the result. We are making use of the additional this one. I'm speaking of the line number 11. You can clearly see we are making use of an additional DP array of size n to store the results, right? So I hope the complexities are clear. So the time complexity and the space complexity for the code that we have written as big of n. I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching.